Now we're going to keep going with rational expressions, and we're going to talk about adding and subtracting rational expressions. So in order to add or subtract, it's a little bit more difficult because you have to have a least common denominator, just like when you add regular fractions. So if we're adding and subtracting rational expressions, we have to make sure they have the same denominator, which you're going to see the same denominator means the same factors have to be present in both equations. So if I look at this, I have a common denominator of 9, so I can just go ahead and add that, no worries. In this one, I have a common denominator of 3x cubed. I can subtract 8 minus 14, no problem. Notice the denominator is not changing at all, okay? I can then simplify negative 6 and positive 3 to get negative 2 over x cubed. That's a place the lab is going to get people because you've really got to check about it being in lowest terms in this section. Here's another one. I have a common denominator. I'm just going to combine them into one fraction. I'm going to factor to see if I can cancel, and I can, so I get a fully simplified answer. Here, two polynomials that are the same. I'm going to add them together. The denominator does not change. I'm going to factor. I can cancel. And there's my simplified expression. So what do we do when they're not the same? Well, when they do not have the same denominator, we're going to factor the denominator. Then we're going to find the least common denominator, which just means that every denominator has to have the exact same factors. It's not like when you're trying to do fractions and you're trying to get different things. Every factor has to be present in each denominator. So if I was looking at these two, I would notice that the 15 needs an additional A, and the 10 needs an additional B, and then my numbers have to be equal. So I'm going to factor that 15 down, and then I'm going to work on getting those factors to equalize so that 30 from 2 times 5 times 3 is 30. I have 3 A's here, so I need this one to have 3 A's. I have 6 B's here, so I'm going to need 6 B's, and that's my least common denominator. With Z and Z plus 6, these are already factored, so that my least common denominator is just the multiplication of the two. So it's a little bit easier when we have factored polynomials. Here's another example. So that's my least common denominator. It's what I'm taking all the factors from each one. I'm not writing factors repeated, but I'm taking the factors of each one. So I'm factoring the statements, taking the factors from each one that are in common, and creating that common denominator. So let's look at some problems. If I have m and 4m, I need every factor to be present. So I need that 6 over m to become 4m. So I'm going to multiply the top and the bottom by 4. That gets me the same denominator, and then I can combine the fractions. Here I have a y and a y plus 4. I need to have a y plus 4 in the left fraction and a y in the right. So I'm going to multiply the first fraction by y plus 4 over y plus 4, and the second fraction I'm going to multiply by y over y. Once I do that, I get my common denominator, and I'm able to combine it into one fraction. Then I'm going to factor it. So this is actually going to factor because I have 2y minus y, not factor, it's going to combine like terms. 2y minus y is 1y. I'm left with that plus 8. Chances are you're not going to be canceling things out here. You're going to be combining like terms. Here, look at that. I have a common denominator, so that's beautiful. So I must do the subtraction, and I need to be very careful that I distribute this negative from the subtraction statement. Then I'm going to combine my like terms. I'm going to double check it. Does it factor? Does anything cancel? And the answer is no. Well, the answer is yes. Sorry, you're going to factor a 3 out, and then they are going to cancel for an answer of 3. So in the lab, just double check that factoring because 6x plus 21 didn't look like it was going to become necessarily 2x plus 7, but it did. Here, I need to subtract, but r minus 2 and r minus 1 are not the same. So I'm going to multiply by the factors of the other fraction, top and bottom. I'm going to combine my like terms once I get one fraction. I'm going to try and cancel that to see if it does factor, so I can cancel, and it doesn't. There's no factors of 4 that are going to add to be positive 1, but give me a positive 4. Here, it looks very similar, right? But they're not quite the same. So I can multiply the expression by negative 1 to flip it around. So now I have a common denominator, and I can combine 2 plus negative 1. Here's 3. I have 3 fractions, so I need a factor from every fraction to be present. So I'm going to multiply this by x minus 5 over x minus 5 to get the x times x minus 5. And I'm going to do the same thing here to get that x over x minus 5. I'm going to combine them, and I'm going to combine like terms to get 2x over x. The x's cancel, and I get 2 over x minus 5. So if you notice, this is an x minus 5. The least common denominator is going to come from here. If I factor an x out of this expression, I get x times x minus 5. Here I have an x minus 5, so I multiply by x over x. Here in the second one, I have an x, so I multiply by an x minus 5 over an x minus 5. Here, I already have x times x minus 5, so I don't multiply by anything. Now, what if we want to subtract? Well, this is a little more complicated. I'm going to have to factor both the denominators to really get an idea of what factors are here. It looks like I need to have a plus 4, an a minus 1, and an a plus 3 to get all of my nice factors together. I'm going to go ahead and multiply the top and bottom by what's needed in each fraction to achieve that. I'm going to distribute the values at the top. Then I'm going to subtract, keeping in mind that subtraction symbol is going to distribute to both terms in the top. Then I'm going to combine my like terms. I'm going to factor out anything that could be factored out. So here you could factor out an a and get negative 5a plus 1. That would be what the lab would want you to do. It doesn't cancel with anything, so it doesn't change much, but it's still going to be lowest terms. Here's the same thing. I have quadratics. I'm going to have to factor them. Well, they have p minus 3 in both, but I need 2 p minus 3s and a p plus 5. So I'm going to multiply to get that to occur, distribute, combine like terms, and if I can, I'm going to factor and cancel, which it doesn't factor and cancel.